what is this?
Surprise.
This is indeed a surprise because I thought it's just a plain box.
So,
Wow.
it's not. I don't have ice cubes though.
I don't use ice cubes in whiskey.
That's a good thing.
I
for
prefer
you.
straight whiskey.
Did you also think that this is empty?
I didn't even notice it. And I'm surprised that I didn't notice it.
Oh,
Single malt, aged 14 years.
yeah.
Oh, this is very and it's matured in rum casks,
Yeah.
and I also like rum.
Really?
So I'm really curious about
Spot on.
how this will turn out.
Good evening, everybody. Today it's a special day for a lot of our viewers. They might be surprised because I have a lovely guest today. Some of you know him, some of you admire him, some of you don't know him, which makes sense. It's Angelos. Should I say your last name as well, or you don't mind?
Since you saw my face, you can say my last name also.
Okay, Seizas.
And because most people can't spell properly my name, even in Greece, so
Really?
yes.
That's strange. Is it? But Seizas. But you have the escalation mark and your
That's something that only people who know Greek can understand. Why Greek people can't spell my name. So.
Okay.
Let's say that everybody calls me Seizas, but my actual name is Seizas.
Yeah. Well, I can assume some people in English is a bit difficult to do this switch between the two.
Well, in English they can't even spell my first name. They say Angelos every time, even though every time I introduce myself like Angelos. Oh, yeah. Angelos. Oh, hello, Angelos. Yeah.
It's not that bad actually. You have to appreciate the effort though. So, today we'll speak for a very interesting thing. Some of you don't know. I don't know anything. Well, I might know a bit. Yeah. So, we are talking about physics today. Mm-hmm. You are a student in Cardiff University. Right. Student. And actually, I would like to ask, like, what was the first touch you had with physics? Like, how come you chose physics?
That goes a long way back.
As a field.
Because I was always a curious child, and when I was a child, I always, instead of focusing on my studies in elementary school, I preferred to read encyclopedias or scientific books for kids, of course.
Was this more like interesting to you?
Yes, it was more interesting because in school we learned about spelling, mathematics, basic mathematics, geography, but I was more interested in astronomy, chemistry, physics, stuff that we, at the moment, we didn't learn in school at that moment.
That's why you went to Cardiff to...
that's...
It came later, I guess, as I thought. It didn't come when you were young.
Decades later.
I understand.
I was very interested in science when I was a child, and I even made a laboratory by myself.
Okay.
I could make... I was able to do electrolysis. And separate water into hydrogen and oxygen. Really? And I remember every morning when I had to go to school, the first thing I did was to connect a battery to some electrons and add it to the solution of water that is needed to make this reaction. And when I returned back...
did you make them again?
After 6-7 hours, I don't remember... I had two, how is it called? Tubes.
Yeah.
And I collected the two gases in those two tubes, and I liked to light some matches
and
to see the explosions. I also made some lamp, a night lamp, because I liked to sleep with some light, and I made a lamp by myself. I made a simple circuit.
How did you found did you had a gas lamp, or you bought the lamp and you made the
No, I just made the circuit by myself.
Okay.
I mean, I just stole some cables.
I left it.
From my neighbor. I took them from my neighbor.
Borrowed.
I borrowed. Yeah,
I made a switch by myself with some nails and how are those called in English? Seizas. How are those called in English?
Switches. They call them switches. Yeah.
All right. So yes,
Door switches.
Yeah.
door switches and nails, and I made a do-it-yourself switch.
Okay.
You basically used every piece of iron that you could find home and steal.
I also liked to make chemical reactions. Everything that looked chemical in my house, like chlorine or lemon juice or whatever. I like to combine all those liquids to see how they will react, and I'm surprised that I'm still alive, actually.
That's what I wanted to ask. Like, did you know about those stuff, or you just saw
It was
a small,
mostly,
a small percentage, and the other one was like DIY, find it by myself?
Mostly it was too experimental, because I really didn't know how it will turn out. But sometimes I just read in my books that this reaction will turn like this or that, and I was curious and I wanted to see.
So you were
I wanted to see it myself.
Experimenting yourself into those to make like curiosity. Basically, is like, is this true or is this like?
It was
bullshit?
very interesting because I found some reactions. I can't even remember how many liquids and what type of liquids I combined, but I made a kind of liquid that it started to produce some bubbles, but in a elliptical way.
Okay.
And I don't even know how I managed to produce this. One of my favorite reactions was when I added iodine in bread, and the bread turned into a blue color. A very blue color. Imagine bread, blue bread, literally blue bread.
I hope you didn't eat that after.
Oh, of course not. I wasn't that stupid, okay.
So moving couple years later, is that something that you continue growing, I guess, on that one?
I was so invested in this. I loved science so much. And I loved experimenting. They even had a telescope, and I made notes every time I was doing some experiment. And also my knowledge was advanced for my age on this field, because I remember when at the sixth year, it's called sixth grade, I don't know in English.
Yeah.
It was the first time that it was the year that we started to learn about physics. And so we started to learn about very basic stuff like what is energy, what are forces, what are the types of energy, etc. And I already knew that, and I already knew about the existence of quarks. Something that I think not even in high school you learn.
So, since you were a bit like...
Not even your teachers.
Maybe some they knew if they were like, some people do more than just teaching. But you don't know this until they finish work and experiment that. So after you finish with all like school obligations,
No, like, we are still in this period because
I mean, I don't mean university obligations. I mean like high school, and then when you are, because to get a university degree, basically it's a person's choice nowadays. Like it's not. I don't have to do it unless if I want to do it, or if my parents push me to do it. That's a lot of different things and cultures, But basically, after like you're 18-year-old, you stop. It's how, let's say, they give you like the basics to walk in life. And then if you want advanced knowledge, you go to a university. Yeah. So when you finished that, was it because I know when you stopped, you didn't start immediately university, yeah?
Yes.
So
and there's a reason for that. I will. This is what I'm going to explain right now.
Yeah. Did you had like the same need, or you wanted to try to find out how you can manage to go to university?
It was more tragic than that because as I said, I was so invested in this thing. I loved so much what I was doing with my experiments, with reading about physics and chemistry, and many people of my age, they bullied me about this. All right,
about physics,
about my interests. About my interests. Yes, and they called me crazy scientist and stuff like that. And back then I was more sensitive than I am now.
Yeah.
And this influenced me in a way that made me think that it made me think that engaging with these subjects is something to be ashamed of.
Okay.
Because I only received negative responses actually.
Yeah.
From people. People who did not bully me, they never said, that's very interesting, or congratulations about what you're doing.
Okay.
They were just indifferent. So I had only negative feedback. And I think that's what made me think that being in love with subjects like physics or chemistry or astronomy is something shameful.
Okay.
So this is what made me stop engaging with.
You stopped for a while.
I did stop. Yes, I said. Before that, I said when I grow up, I want to be a scientist.
Okay.
That's it. But after that,
You took a break.
No, not a break. I said I will never again. Yes. And I found other interests like information technology, but people started bullying me for that too.
Okay.
Yes.
That's normal, you know. You didn't change.
Is that though helped you? The fact that you choose something different, like people just giving the same feedback that gives you, like, you know, if I get
find another passion.
This one.
This one was a passion for me also.
Yeah.
And I think it almost happened the same thing. I mean, I started to feel that it's something to be ashamed of.
Yeah.
All right. And when I turned 18 and it was time to decide what you have to do with your life, to decide about what you have to study, I wanted to study conservation of antiquities and works of art, because this is what I also like antiquities and art, and especially their conservation.
You draw also, right?
Yes, this was one interest that I discovered when I started to feel ashamed of my other passions. Sorry, and
fine.
But in Greece, strangely enough, in Greece there is only one public school and one private school about this subject, and this is pretty weird because I mean in Greece you have so many antiquities and works of art that need to be conserved, and
not a lot of people maybe care nowadays to do this
but
kind
it's
of
strange,
job.
you know, because you live in Greece. This is
plenty of opportunity.
And museums in Greece bring people from France to do this job. Yes. So I gave the exams.
For this.
Functional examinations, as they're called. This is the equivalent to the A levels in UK. But the school
didn't accept you.
No. It's not that. It didn't even form the class. There were not enough people. Not in the public school, neither in the private school. Yes, and I didn't know what to do, so I just chose an almost random option.
Random.
Yes, it's related to civil engineering.
Okay.
But what I thought was, okay, I don't want to waste another year.
So what happened that changed you and you came back to what you used to love in the past and you decided to go
There's
to
a short
university?
answer, there's a long answer, and I'm going to answer both of them. The short answer is that I matured.
Yeah.
And the long answer is that when I started studying in this field, in this vocational training that's related to civil engineering,
Building design.
Yeah.
building design and geoinformatics, we also had courses related to physics, thermodynamics, and mechanics, and I was very good at those fields, those modules, sorry, and so good that I scored 10 out of 10. Even better than the best students in my class.
Yeah.
Nobody expected that, not even me. And that's how my interest in physics
Came back again.
came back. Yes,
Reborn.
Reborn. It was
After
reborn.
10 years, like.
Maybe, no, yes.
And is that like, did there, when you, because you were studying like a science,
There was another factor also.
that did anybody from there, when you were good at physics, like contributed to say like, oh, do you like those stuff? Or
No, but there was one professor who somehow already knew that I'm going to.
To smash everything.
Yes. I don't know
to
how.
be good.
Yes, but this certain professor, who was a physicist, by the way, he said that I'm going to ace it.
Yeah.
But there was also another factor that made me make this turn back to physics, because when I started to work again, and I spent most of my days working, and when I came back, I was so tired that the only thing I did was to eat and sleep. I started to make some existential questions, like, all right, if my life is going to be like that from now on, why not do something that I really like?
Yeah.
And that's how I decided to start studying physics, and because I wanted to, if I had to work, I want to do something that I like.
Do something that
maybe it's miserable, right? But I do something that I like.
Yeah, well, or get inspiration of. I see what you mean.
And I also started to. It was that time that I also started to read about the lives of famous physicists.
Okay.
And this is what also contributed to my decision.
When you are young, you are not really thinking about those stuff. And when the time passes, you realize you're like, you know what? Some people, they turn like 60 years old and then they have a middle age crisis and they do all shit that they do because never in their life had that realization, isn't it? So I guess after that, you've passed, you decided that you want to go to university, found the best options, I guess. English, it's a very, we learn English in Greece.
First of all, I didn't want to study in UK because I'm broke. But
that's a good start for a physicist.
yes, indeed. But Greek bureaucracy is a more formidable monster.
Okay.
Because when I started to feel ashamed about my interests and all that, and I didn't care so much about all these things, when I had in Greece we have two types of high school. We have
the good one and the bad one.
Yes, the good one and the bad one. This summarizes well what it's about.
The one that the parents pay and the other that parents don't care.
So I went to the bad one. And because even the Greek state acknowledges this, that the one is the bad, the other is the good. They don't allow you to give the Panhellenic examinations for some subjects like physics if you are
from the lower class.
You cannot become a physicist if you go to the bad.
Exactly.
You cannot give exams to do it.
You know, this is absurd because
it is. You learn
if you spend like 1 or 2 years studying by yourself and dedicating so many hours preparing for the examination, why not give him the opportunity to...
Yeah.
So in Greece, you don't have this opportunity.
Now you do have it, but
now
back then you didn't.
Them, yeah. But it's still what you learn, it's a bit different as well.
Well, for in Greece, for the educational system in Greece, especially back then, they didn't care what you know. They only cared about your papers.
Paper.
So I didn't give up, and my philosophy was and still is that failure is not an option.
Yeah.
This is how I made it so far.
That's a good...
Because most people will say, I can't do this, all right, I'll find something else. For me, this wasn't an option. So I started looking about how can I study in other countries?
Yeah.
Of course, because I only knew English besides Greek. I first started
How
looking...
did you know English though?
I was self-taught by playing World of Warcraft.
See? So the passion for computers taught you English.
Yes, maybe.
But English is very easy language.
Yeah, it's everywhere.
It's everywhere.
And I found out that it's easier to apply for British university because back then the UK was in the EU.
Europe Union?
Yes, in the Europe Union. And I could get a student loan. Maybe that's one of the most...
important factors.
Yes, because as I mentioned earlier, I'm broke. And I started to send emails to every university in the UK that had a physics department. And I sent them my qualifications, asking them if they could accept me. And I got offers from 5 universities.
Okay, that's not bad.
Yes.
What kind of did you show them? Like, what did you emphasize when you sent those emails? Did you emphasize on like why you like
my
physics or what you enjoy doing?
First of all, I had 2 qualifications. One was from my high school, and the other one was from this vocational institute. I was doing this building design degree. My qualification from high school was awful. Because I didn't care about anything back then.
You cared about.
So my grades was bad, even in physics. But my other qualification was pretty good. I had good grades, and I had some modules that were physics related. So when I sent them my inquiry, I emphasized that those modules are related to physics, and I explained them in detail about what I learned in those modules, and this is what actually the admissions teams in universities want to know. They don't care so much. Like in Greece, they only care about formal and typical things like show me this paper and show me these grades. But here in UK, they are more focused on what you know, what you actually know, and what are your skills.
Yeah.
And I chose Cardiff for two reasons. One is because Cardiff is the cheapest city in UK.
Is it?
Yes.
Okay.
Without being bad.
Because, as you said before,
Yes, because
I'm broke.
yes. And the other is because Cardiff University belongs to the Russian group, and it's pretty good in
The Russian group.
Russell group.
Russell group.
Yes, it's a group of British universities that are pretty good in the research area.
They have a good research department and they focus on this.
They have good resources about doing scientific research. And generally, it had a very good reputation. And also, half of my tuition fees were paid by the Welsh government.
Did you learn those? You were looking about those, I guess. You find those on the website of the university.
Yes, in the website. And I also asked through email the admissions team
and they say you accepted then. You've been there.
They accepted me. I didn't even need to send reference letters.
Yeah.
Because they were already satisfied about me.
Yeah.
But I had to do a foundation here because they said that I didn't have a strong mathematics background.
Okay.
Which was true. And thankfully, it was a pretty good idea that I did this.
Did you do it here in UK?
Yes, in Cardiff University. Yes.
So when you went there, you had 1 year which wasn't basically. Was it physics oriented or it was normally at the same time?
Cardiff University, they had a foundation year about physics, but they don't have it anymore because there was not much attendance.
Okay.
They decided to merge this program with the foundation engineering year in foundation engineering. Yes.
Okay.
So basically, the first year in Cardiff University, I was in the School of Engineering, but I was supposed to progress to the physics program, which I did, of course.
Yeah.
And here I am now.
Do you reckon your experience or your knowledge in physics is like in a good stage or compared to where you are in your physics knowledge, like you are in a university? Do you reckon that things that you do there, it's easy to follow, you fall back, or you think you can have like a bigger amount of things to learn?
That depends on the module. For example, what you say is true about when I learn quantum mechanics, because I already knew about this stuff.
Yeah.
Because I'm self-taught. All this time that I spent preparing for the university, and generally when I started to regain my passion, I started learning by myself physics. So some stuff I already knew, some other stuff I didn't know, especially the experimental modules. So yes, it depends on It depends on the module.
I will ask this now. Let's go to the more like scientific side of this. Yeah. What is physics? Because if I ask like 10 people what is physics, I will get probably 10 different answers.
Exactly. Yeah? That's what I was going to tell you about. That there is no standard definition of physics.
Yeah.
Physics is whatever who practices physics thinks it is. All right. But you can give some general definitions that may apply to most of what people think.
Okay.
You can say that physics is the study of natural phenomena.
Okay.
Simple as that.
Yeah. And then from there you have more advanced areas like quantum mechanics or quantum. Is it quantum physics or not? quantum mechanics.
There is a distinction between those two, but let's say quantum physics is the broader.
Is this like more in depth of studies? What is this?
Quantum mechanics is more specific to the phenomena that are studied in quantum mechanics are non-relativistic.
Yeah.
When I say non-relativistic, what I mean with that?
Yeah.
With the advent of theory of relativity, which is one of the most revolutionary theories in physics and in science in general, it was relativity and quantum mechanics are the two theories that brought an entire revolution in our understanding in physics. Because before that, the view that we had about the world was that it was made from tiny rigid balls that were moving like billiard balls, and that space and time they are separate entities, and that they're absolute, meaning that time flows the same everywhere. And this is what we call the classical view of the world in physics. But at the start of previous century, there were some pretty radical developments that led to the formulation of relativity and quantum mechanics, and this change it fundamentally changed our view of the world, because we now know that time is relative, space is also relative. They are interrelated. There is not actually space and time. It's one same entity. It's space-time, as we call it.
How come and you haven't decided to go to, let's say, astrophysics?
When I was a child, I was mainly interested in space. And I was very excited about stars and galaxies. But when I learned about the subatomic particles and stuff like that, I found it more exciting and more exotic. And because one of the reasons that I'm interested in science is because I want to tackle the fundamental questions of reality, and from what stuff reality is made of and things like that. And I think that quantum mechanics, particle physics, subjects like that, those are subjects that will lead you the way to those answers. To understand, those fundamental questions about reality. One of the most usual things you hear about quantum mechanics is that it's it's the most successful theory in physics. And it's true because the predictions this theory makes are enormously accurate, but we have the mathematical tools that predict those stuff, but we don't know what they mean, what they are in reality.
So is this one of the reasons that, let's say, journalists can give us the correct feedback to understand?
Well, I imagine that a journalist just Googles some stuff before writing an article, like what is quantum mechanics, and after one night of read, he writes whatever he understands.
So you reckon what we get from the articles, it's basically not in-depth knowledge, but what's believed in the early stages?
It's in-depth and confusing.
Yeah, is that why a lot of physicists turn into crazy? Is that what it is? Is that what it is?
Probably. Yes, I may say things a little chaotic, and maybe I confuse some people, but I can't help it myself. This is how I talk. When I write, I'm very rigorous, but when I talk, this is how it is.
Do you reckon that physics help this, contributes to that, or no?
No, I wish it could, but only in writing.
In writing?
Yes, in writing I can be very analytical, very rigorous, but when I talk, it's more chaotic. It's more...
Okay. If let's say, which one is your favorite scientist from the past?
No. Let's do it a little bit differently. Do you think Einstein is overrated?
No, he is not.
I think I ask who is your favorite because I think you won't say Einstein.
Yes, I won't say Einstein, of course.
Yeah. A lot of people won't say Einstein, but if you ask them, they will be like, yeah, he was one of which contribute like a lot.
Yeah, he is a giant of physics.
Which one is your favorite?
One of my favorites is Feynman, Richard Feynman.
Feynman.
Yes.
And why
a
is
great character.
Why is your favorite?
Because
what does make him one of your favorites, let's say, that some other scientists don't have?
Not only because of his contributions in quantum electrodynamics and other subjects related to what I personally study, but also because of his character and his genius.
As a person?
Yes, he was a very charismatic person. He was very, how to say it? I think charismatic explains everything about his personality.
In which
and his childhood reminds a little mine.
Like Grinder.
He liked to disassemble radios to examine them. He made mathematical. He invented a mathematical notation by himself. Because he thought rightly that the usual notations we use in mathematics are a bit confusing.
Okay. Well, in this, which...
he is inspiring.
Yeah?
He is very inspiring.
In which time frame did he live? It's not alive still, no?
20th century.
So
last century.
It's a recent science. In the new group of scientists, yeah?
Not a new group of scientists. He's not recent anymore.
Was it Einstein, the first person who found the quantum mechanics? Was it his one, or were people before
Einstein
him?
was one of the first physicists who led to the advent of quantum mechanics, because first of all he did not discover, he interpreted the photoelectric effect. What is the photoelectric effect? It's a phenomenon that when you shine light on a metal, it will emit electrons.
Yeah.
And because back then light was understood as a wave, and the energy that you receive from waves, you receive it in a continuous manner. So the energy you receive from a wave depends on the intensity of the wave, and that this means that if you shine a very faint, let's say a very faint beam of light, it will emit some electrons.
Yeah.
A few of them, but it will emit. If you shine a very bright beam, it will emit a lot more electrons. But this is not what happens. If you emit a very faint beam, no electrons will flow. They will start to flow up to a certain point, up to a certain energy and beyond. And they didn't know how to explain this. And Einstein managed to explain this. by interpreting light as a stream of particles, photons, quanta, as they term them, and this explains why a faint beam does not emit electrons. And why is that? It's because electrons are bound on atoms.
Yeah.
And to knock out from an atom an electron, you need a certain kind of energy. You need
a certain amount.
A certain amount. Sorry. There is a term called binding energy.
Yeah.
Binding energy is the energy required to keep an electron bound on an atom. If you hit this atom with a photon that has energy lower than binding energy, the electron will
not move. It will stay.
It will not be knocked out
atom.
of the electron. It may change orbitals or something, but it will not leave the atom. So you need to
overcome
a threshold. Yes, a certain threshold of energy.
Yeah.
So Einstein said actually that light is discrete. It consists of quanta. And this is one of the things that contributed to the formulation of quantum mechanics.
Is it for all atoms the same energy that you want? So you will throw
it depends on the atom. Depends on
the atom.
Of course, because not on the atom, of the element of the atom.
Okay.
If we are to be more precise.
So it wasn't Planck.
Planck, Einstein based his interpretation on Planck.
Okay.
Because Planck explained some discrepancy in a certain electromagnetic phenomenon by explaining that energy is discrete and not continuous.
And I guess at the time that was like a big change in how they understood the world.
It was radical. It was not just a big change. It was radical.
Yeah.
It changed the entire worldview that we had about the universe.
I think most of the times when something like this happens, people are a bit more like conscious, or they think like maybe that's not a very, very true.
They are conservative every time something so radical.
Einstein had the same pushback, like what you say is bullshit and it's not existed and things like this, or no?
Yes.
Do you know? Or
initially there were a lot of
opposition.
But it was inevitable that relativity will
be proven
as
the way of.
We think that Einstein was the sole actor in the rise of relativity, but that's not true. There are a lot more scientists, even before Einstein, who worked towards relativity. But Einstein made the most decisive, the most decisive steps, maybe. I can't find the right word right now. There are scientists like Minkowski, like Poincaré. All those scientists contributed to relativity.
And then it's like when Einstein were there, just everything clicked.
Einstein, how to say it? He was the one who made a theory out of all this.
Okay.
But what I want to say is that if there wasn't an Einstein, there will be someone else.
Okay.
As a physicist, there are some fields that you don't really like, right? Are there?
Yes, I think. Maybe a more accurate word will be boring.
Like what? So tell us a field of physics that you find boring.
Physical chemistry.
What is this about?
It's about physical chemistry.
For example,
it's where chemistry and physics are combined. So you talk about how atoms bind together, how they react with each other, molecular bonding.
So they are boring for you because you used to learn about them when you were 5.
They talk about objects that are too big for my liking.
Too big?
Yes, too big for my liking. Molecules, atoms, I prefer subatomic particles.
It's like geology, the disgrace
No,
of
geology
science.
is interesting. There are some exceptions. Geology is good, all right. But what I like from the usual everyday world is meteorology.
Really?
The climate science.
When you finish your university obligations, let's say, and the things that you study, which is more like technical, is more like what people ask you, well, professors ask you to learn, and you go home and what is this that feeds this need for you to learn more? What's like gives you, let's say, lights up the fire for you to want to learn something more?
Well, curiosity is the most fundamental thing of it, and this is why I also sit down and read about extracurricular things. I already, when I was at the fixed year in university, I already started reading about quantum field theory, which is something that we learn in my year now, in the final year. And I'm curious because I have a lot of, let's say, philosophical questions.
Okay.
About what is the substance of reality. One of the reasons that I like particle physics so much and quantum physics. And generally ontological and metaphysical questions. And what I realized is that, as I said earlier, in university you learn some recipes about solving problems. You're not focused so much on understanding. For me, physics is something that is not easily distinguished from philosophy. When I started studying physics, I expected to get a better understanding of those questions at hand. But I realized that in physics, you merely build some models, most mathematical and interpretive models, and you use those models to make predictions. And the value of those models, either you call them theories or whatever, the actual value of those models is not that they say something true about reality. They say the value is that how successful they are in their predictions.
Okay.
So if you are someone who is more philosophically inclined, this is not enough. And this is something that I realized later. But it's also something that's vital for a physicist. Because without philosophy, you will remain within those methodological limits and whatever other limits they put on you through education. And if you think about it, every scientist that revolutionized their field, they were also philosophers. Einstein, for example.
Judged as well, no? They judged as well from the people, the dogmatic people at their years.
Yes, that also. Einstein was very educated in philosophy. You can even call him a philosopher, not just scientist. And every other great scientist of that age, they were also engaged in philosophy, like Niels Bohr, Heisenberg. And this is something that is lacking in our day.
You recollect that we take the occasions...
Because in our day, this doctrine that I said earlier, that I called earlier scientism, reigns supreme. The idea that only science can light our way towards enlightenment.
Yeah. But like, is it like science something that we should like try to prove and then at the same time try to disqualify it as well to find something better?
You cannot exactly define what science is. There is not a strict definition of what science is, exactly because there is not a single methodology used in science.
Yeah.
What we say, what we call scientific method, it's not something monolithic.
Yeah.
It's something that changed over time, and it's something that's different in different disciples. And for some reason, most people do not realize that. They think that it's something standard. But if you think about it, if you look at the history of science, you will see, for example, that people like Newton or Galileo will be considered unscientific with the standards used today.
Yeah.
So, for example, Galileo, when he presented his work, his work wouldn't fit with the criteria that is required now from the scientific community. His instruments were not accurate enough to make as confident results as he would like to present. There were not large statistical samples, let's say, as are required now. And generally, the empirical evidence to back his right theory, because it was proven right later, it was not enough for our standards.
Yeah, at that time.
So if someone does something in an unorthodox way, you're not going to accept this.
Yeah.
You will consider this unscientific or something, heretical. Back then, it was considered heretical. Heretical didn't mean just that you were against religion. It means also that you were unscientific or generally unorthodox. Now we say unscientific. All right. So one thing that counts is that people say, no, you need to play by the rules. The other thing is what you say, it's psychology. There are, how to say it, there are more, some minds are more conservative than others. It's not so open to ideas or whatever that are, that question fundamental beliefs or ideas that those minds have. So yes, psychology does play a role, and Thomas Kuhn emphasized this. Thomas Kuhn is a great philosopher of science who explained how scientific revolutions work.
Okay.
And his philosophy is very sophisticated, and we can't just I can't just explain it in a few words, but I can say that one basic thing that I can explain from this is that when someone presents a new paradigm in physics, there is resistance, especially from older people, because of that, because of some kind of conservatism. Those people grew up and learned some very specific paradigms, ideas, and more difficult for them to abandon those things.
Yeah. Do someone needs to be smart to study physics?
Well,
does somebody needs to be smart to study physics? To be a physicist.
No and yes. And I will explain what I mean by
Very complicated answer.
Yes, it's a complicated answer because to understand physics, you don't need to be smart. You need to train yourself you need to familiarize yourself with the mathematical methods needed to tackle the problems and issues of physics. And this is not something that only smart people can do. It's the same thing with things like learning a language, right?
Yeah.
Some people deemed smart can learn language faster than other people. But even dumb people can learn languages. Yeah. This is the same thing with mathematics.
They just need more time, you reckon?
Everyone learns with a different way.
So it's the way you are learning and the method you are learning that will help you.
Yes, it's different for different people. It's not about intelligence. If you understand what is the most efficient way for you to learn something, you can be the best of physicists or whatever. Yeah. It's not about intelligence.
Does it need any creativity, let's say?
Yes, this is what I was talking about, because to learn physics, you don't need to be intelligent. To revolutionize physics, maybe you need some kind of intelligence. Surely you need to be smart enough to not remain within dogmatic limits as most people do.
Like you say, like they never question some principles and they just use them as like fundamentals.
Well, this is not entirely their fault. It's how people learn about how people teach about physics, how they learn about physics. Sorry, and what I don't like about physics education is that the general approach to this is the so-called shut up and calculate approach. Yes, this means that
very subtle. Very subtle.
This means that if it happens that you have some kind of question that is deemed to be philosophical or something like that, the answer that you usually get is along the lines of shut up and calculate. So they will say this is either meaningless or this is unrelated to the subject and it's philosophical or metaphysical or whatever, and that the only thing that matters is that you learn those specific methodologies, those specific skills. Yes, so you learn how to solve problems actually with some rigid ways, and this is very limiting. You are just actually trained to. You are trained at problem solving, but within some certain methodological constraints. Creativity is not encouraged as much as it should be. Yes, because as I said, the basic thing that you learn in education is that this is a set of skills or methodologies or whatever you like to call them. This is what you will use to solve problems.
If a person wanted to go into physics, what would you say to him to inspire him or to motivate him to do this?
If they need me to inspire and motivate them, then they are already doomed. They need to have motivation already. They need to have this passion for physics.
The curiosity.
Yes. if you want to study physics, I assume that you love the subject. All right. So I don't need to say anything about it. I don't think that I need to say something to motivate people, except if they are in a situation similar to where I was. I mean, if they get bullied about this, they should know that it's not something to be ashamed of. It's not something that only weirdos do.
Yeah.
In my university, most people are normal.
I think a lot of people are normal.
Yes. Yeah. Normal people like physics. This is what I have to say. All right.
Yeah.
This is considering my background.
Yeah, that's what I'm saying, because a lot of people might wanted to do it, but nobody.
Yes. Also, something very important is that it's not as difficult as they think, because as I said earlier, you don't need to be smart to study physics. It's only a matter of training, a matter of patience, of course. They will understand once they start, but they should know that how to say it. Yes, if they think that they are dumb, it's no matter.
It doesn't matter.
Yes, it doesn't matter.
Yeah. Dumb people can do science.
Who knows? Maybe they can become smarter while studying physics.
Yeah. Well, personally,
but it doesn't matter.
I'm curious about those things. Yeah. I don't have in-depth knowledge.
Mm-hmm.
I have another thing though, that when I study too much theoretically, I tend to fall asleep. So for me, it's a bit harder. I haven't found a way for me to study theoretically.
You can't concentrate.
Yeah, possibly. That's what it is. But
that depends on different people learn things differently. Someone might fall asleep by reading and might find that he's able to concentrate only by watching lectures. Some other might find it easier for him to concentrate if he listens to audiobooks or whatever. So I can't give a specific answer to this, because it depends on how you learn.
Yeah.
You need to discover your learning
methods.
Methods, maybe, yes. Your psychology. It depends on your psychology. It's a matter of psychology.
Yeah, I see what you mean. Make my brain think that what I do.
Just try to realize how it is easier for you to acquire knowledge through images, through reading, through hearing, or through a mixed kind of.
For me personally, it's mostly like try and fail and try again.
If you have the patience, it works.
That's what I do. Like success through failure. That's how I call it. Because if you like something, and eventually it's something that happened to you as well, even if you get discouraged, it's something that you like. It's something that gives you. But
there is something important
feelings.
also to note about this. It's you don't need to remember the details. You don't need to spend so much energy on. I read this page
to
and
memorize. Then you don't need to memorize.
Yes.
Stuff. It's more like understanding what I read.
If you get the general understanding, that's enough for the beginning.
Great.
Then if you have to study a specific subject and you need some revision, it will be easier to just go back and read those pages again, because you are already familiar with this kind of material, and you may not remember it, but once you read it again, you say, I remember now this. And you won't need to put so much mental effort again like the first time.
I see.
So this is another advice I will give to once you read, don't put too much effort, too much attention to details.
Yeah.
But put effort on understanding.
Yeah. You have to understand what you are reading, and then you guess that you will be fine afterwards.
Yes. Just don't how to say it? Don't worry about the details if you don't remember them.
Yeah.
At that moment, if you gain the understanding, if you say, I understand this now that I read this page, no matter if you don't remember the details later, no matter if you don't remember how to derive a specific formula or something, or if you don't remember all the principles of a theory or whatever, if you understood them once you read them, and if you were concentrated on that, then you can go back. You say, I need to remember this part. I know where to look. And then you look up and you read those pages again and you remember and you say, yes, this is
got it. Easy.
Yes.
Piece of cake. Okay. Thank you, Angelos, for being here today. It was very random, actually, to have you here.
It was random, and also I feel, and my flow is random also, and chaotic, which is something I don't like, but okay.
Scientist. I hope you enjoyed it.
Of course.
I hope, guys, you enjoyed it as well.
We had alcohol.
Yeah. I notice a lot of physicists drink a lot. I know. I hope, guys, you enjoyed it as well. Have a lovely rest of your day of what they're doing. What are you doing? Until the next time, goodbye.